Hello everyone, and welcome back to NL 582, Modeling and Control of Electric Machines and Drives. And today's tutorial is about the V over F speed control of three-phase induction motor. Like we said, it is the most important method of speed control of three-phase induction motor, the most widely used one. And we need to dig more about it and to just solve a couple of problems to try to understand how this actually works. Okay, so here's our first problem. I can stress it more. If you didn't have time to look at the lecture talking about the V over F speed control, you definitely need to go back, and even you need to revise it before jumping into this tutorial. It will be much help for you, because I will not re-derive all the equations and all the stuff we have already covered in the lecture. So the problem here said that you have an induction motor is operated with a drive that supplies rated V over F below rated frequency. So this is just giving you a V over F speed control, and he said here it's working at the rated V over F ratio below the rated frequency, which is actually the typical way of doing the V over F speed control. The motor has 6 poles, so the number of poles is 6. So let's extract the data here while we are reading. Okay, so the number of poles of the motor, small p, equals 6. Rated frequency is 60 Hertz. The frequency rated is 60 Hertz. And rated torque 30 Newton meter. The torque rated is 30 Newton meter. Occurs at 1160 RPM. That means that is the NM rated at 1160 RPM, because he's saying that the rated torque occurs at that speed, and that means that is the rated speed actually. Okay, because basically the rated speed is the speed of the rated load, which expressed by the rated torque here. Okay guys, number A is to calculate the rated slip speed in RPM and slip frequency in electrical radians per seconds. Okay guys, so let's try to find out here what you're talking about. Before jumping into this, I hope you remember this curve of the V over F speed control. I just will draw it here to remind you what we did about it. So we have the rated frequency here, which for 60 Hertz for this problem, because it's given here, the rated frequency is 60 Hertz. And this is here going directly at the rated voltage, V rated, of the machine, which is not given here. And if you remember, we have here the 1/4 of the rated frequency, which is for here 15 Hertz, because the rated frequency is 60. Okay, this we add a little bit of boosting voltage to just account for the voltage drop over the stator impedance. Yep. For this, we have a linear relationship of V over F, and here it's fixed at the boosting voltage. Okay, so linear relationship here means the V over F ratio keeps constant at the rated value all the time below this. Okay, and after this you can no longer increase the voltage over the rated voltage. That's why we keep it constant after this. Okay, just to remind you how we did this. So number A wants you to calculate him the rated slip speed in RPMs and slip frequency in electric radian per seconds. Okay, so number A, he wants you to find him N slip, NSL rated, which is basically the synchronous speed minus the mechanical speed rated. Okay, that's also the synchronous speed rated. What I mean by synchronous speed rated, because in all for V over F speed control we're changing the frequency, that means the synchronous speed itself changes with different frequencies. That's why we now have different synchronous speeds. We didn't use to do this with all solving problems before with the induction motor, because we didn't change the frequency, we didn't change the synchronous speed. So the synchronous speed keeps constant, while the mechanical speed changes with the change in the load. Yep. But for here, we're changing the frequency to control the speed, and that means we're changing the synchronous speeds. We have different synchronous speeds. That's why I'm saying here the synchronous speed rated. That equals 120 F rated over P minus NM rated. Okay, 120 F rated is 60 Hertz, number of poles is 6, minus the NM rated is given to be 1160 RPM. So this will give you 40 RPMs. That's the slip speed rated. Keep in mind I'm talking here about the slip speed, not the slip. The slip is this value divided by the synchronous speed, so don't get confused. Okay. Okay. And what about what he wants you to find him? The slip frequency as radians per second. Okay. So he wants you to find him the omega slip the electrical radians per second. Okay. Which basically equals P over 2, which is the number of poles, over omega slip mechanical. If you remember, any electrical speed or electric frequency, electric speed actually in radian per seconds will equal all the time P over 2 multiplied by the mechanical counterpart of it. Okay, guys? So that equal P over 2 omega slip mechanical, and that basically rated because he wants you to find him the rated value. We just found N slip, which is the RPM. So we just gonna transfer this to radian per second. So I'm gonna multiply it by 2 pi over 60. That's 2 pi over 60 N slip rated. Okay, guys? So this equals, the P equals 6 over 2 multiplied by 2 pi over 60 multiplied by N slip rated, which is 40. Okay, guys? That is actually will give you 4 pi radians per seconds. Okay, that's it. That's why I was asking you find me the slip frequency in electrical radians per seconds. So that means he wants the omega because he wants it at radians per second, and he's just specifying it to be electrical radians per second. That's why we multiplied it by P over 2. Okay, guys? Number B, rated torque is required at 900 RPMs. So he wants the machine to be changing speed, to control its speed to work at 900 RPMs. Okay, and that is the mechanical speed. That's the actual speed of the machine, not the synchronous speed. That's the speed he wants the machine to work at. And still develop the rated torque, and still the load attached to it, still the rated torque. What supply frequency is needed? Okay, and that's a good question here to dig with. So he wants you NM2, now I'll call it NM new, whatever you want to call it, is now 900 RPM. He wants you to go with this. Okay, and the torque new is still the rated torque. So actually the torque didn't change. The new value is the same like the old value. So what is the frequency now you should be driving the motor at? What is the new frequency you want to go with? Okay, guys? Okay. So first of all, before going anyway, you have to check which zone you're working at. How do you do this? Just look at the speed. The NM new equals 900. Okay? That is equaling 900, yes? Which is basically less than the NM rated. If you remember, the NM rated is 1160 here somewhere. Okay? That means you're reducing the speed, not increasing it. Okay? Or anyway, the whole point is, what is the NS rated? The NS rated equals 120 Fs, or F, let me call it F rated over P, which is 120 of multiplied by 60 over number of poles, which is 6. That is 1200 RPM. Keep that in mind. Your NM new is less than the synchronous speed rated. That means you still in the left zone. You still here because you're just going below the F rated. Yeah? And that means you still in the V over F equals constant at rated value. Okay, guys? We didn't go beyond the rated frequency and the voltage will stop increasing, but now V over F still constant at its rated value. Okay? Forgone anything, if you remember the derivation I've just made, go back to look at it if you don't know how this happens. The torque of the machine directly related to V over F all squared multiplied by the slip speed. That's a very important relationship to keep in mind. Okay? For our case here, V over F equals constant at its rated value. And that means the torque of the machine directly related to the slip speed, like we said in the derivation back in the lecture. That's for V over F constant for the zone before the rated frequency. The torque of the machine directly related to the slip speed. Okay, guys? And what will this go to us? That means the old torque, if it is divided by the new torque, will directly equal the slip speed old over the slip speed new. Okay, because you're saying that the torque is directly related to the slip speed. Yeah? So let's say about the first case we just solved. Okay? The torque was the rated torque because it was want you to look at the rated speed, yes? And now the new torque, he said, it's still the rated torque. The slip speed old was the rated slip speed, which we calculated to be 40. And now it is the new slip speed that we can calculate. T rated over T rated will equal 1. That means the new slip speed equals the old slip speed, which is 40 RPMs. Okay? From this, you can find the new synchronous speed, NS new, which equals NM new plus the slip speed new. We remember because the slip speed basically equals the synchronous speed minus the mechanical speed. Okay? The new speed, he said he wants to be 900 RPMs, and the new slip speed equals the old slip speed, and that is 40 RPMs. So that is 940 RPMs. That is the new synchronous speed, which directly equals to 120 F new over P, number of poles, which is 6. From this, you can find the new frequency directly to equal 47 Hertz. That's the frequency you need to drive the motor at to make it just rotate at 900 RPMs while still supplying the same rated torque. Okay, guys? By the way, you can find the voltage related to this one if you know the rated voltage. Once the rated voltage is not given, so we cannot calculate this, but you should just know what's happening here because V over F is constant, yeah? So the V new over F new will equal V old over F old. And you can just calculate the voltage new if you had already given the old voltage. Okay, guys? Sounds good. That was number B. For number C, 15 Newton meter torque is required at 980 RPM. So again, he wants you to control the speed to be 980 RPMs while the load changes to half the load before. The torque was 30, now it's 15. What supply frequency is needed? Okay. So that is number C. The given now is the new torque equals 15 Newton meter and the new speed equals 980 RPMs, and he wants you to find him F new for this case. By the way, I keep calling everything new, but yeah, don't be confused. I'm talking about new for this, so yeah, for part C, we're changing. Yep. Okay. So I do the same thing again. I'm still saying that the NM new, which equals 980 RPMs, less than the synchronous speed rated, which was 1200 RPMs, if you remember. That means you're still in the linear region, while V over F is constant at its rated value. So again, still the motor torque directly related to the slip speed like the previous one. Okay? That means the new torque over the old torque, I'm gonna go here back to the rated torque, the first one, will equals the new speed divided by the rated speed. I'm gonna refer to the rated condition, not to the previous one, which is number B. Actually, it's the same thing. Actually, you can go to whatever you want. I'll give you the same thing. But I like to refer back to the rated value all the time because it just gives you a much better view of what's happening compared to the rated conditions of the machine, okay? The new torque is 15 Newton meter compared to the rated one, which is 30, will equal, sorry, that's not the mechanical speed, it's the slip speed, okay? That is N slip new over N slip rated, okay? The N slip new divided by the N slip rated, we calculate it to be 40, if you remember, okay? And that means your N slip new can be calculated directly to be 20 RPMs, okay? And from now we just go like the previous steps, okay? It's just should be easy now. Is from here you can find the new synchronous speed equals the new mechanical speed plus the new slip speed. That equals 980, that's plus 20, equals 1000 RPMs, okay? And this new synchronous speed equals 120 F nu over P, and the P equals 6. So the new frequency is basically 50 Hertz. Okay, guys? We're going the same way here. That's fine. That was part C. For part D, the motor operates at 700 RPMs, that's the speed, with supply frequency 36.5 Hertz. He's giving you the frequency now and wants you to find him the torque. Okay? It is just not very far away. So the givens here is the new mechanical speed, 700 RPMs. Okay. And the new frequency, it's given here to be 36.5 Hertz. And the required here is the new torque. Okay. So again, we'll go the same approach. Okay. Your new mechanical speed equals 700 RPMs, which is obviously less than the rated synchronous speed, yeah, which is 1200. That means you are still in the linear region. That means V over F as a ratio is constant at its rated value, okay? And this gives us the same approach, that is the torque of the machine still directly related to the slip speed, okay? So I go the same thing again. So the old torque, which is the rated torque here, over the new torque will equal the slip speed rated over the slip speed new. Okay? Okay. The rated torque is 30 Newton meters over the new torque, which is the objective of this solution, equal the rated slip speed, which is 40 RPMs, divided by the new slip speed. Okay? So we need to find the new slip speed here, which equals the new synchronous speed minus the new mechanical speed. Yeah? The new synchronous speed can be calculated by 120 F nu over P minus the new speed. That equals 120 but 36.5, which is the new frequency, which is given here, over P, which is number of poles, 6, minus the new mechanical speed, which is 700 RPMs. Okay? This gives you the new slip speed to be 30 RPMs. Okay? So this goes directly to here, and now you have everything you want to just find the new torque. So the new motor torque for this case will be 22.5 Newton meters. Okay. Okay. So that was number D. Number E, the motor operates at actually that was the number E, 15 Newton meter torque is required. So it wants a torque at 15 Newton meter at 1300 RPMs. What supply frequency is needed? Okay. So let's look at this. Sorry. So here I'm gonna go to number E. It said that the new motor torque equals 15 Newton meter, and the new mechanical speed is 1300 RPMs. He wants you to drive the motor to work at this speed, which is 1300 RPMs, and still develop a torque at 15 Newton meter for the load. And wants you to find him the new frequency you want to drive the motor at. Again, we're going the same approach. Look at the new mechanical speed. This one equals 1300 RPMs, which for now higher than the rated synchronous speed, which equals 1200 RPMs. That means you are now beyond the rated frequency, and now you're no longer in the linear region. Okay? That means V over F is not constant anymore. Rather, V is constant at V rated, because we cannot increase V over its rated value, but we cannot increase frequency over its rated value. It's fine. Okay? So I'm going to go again at the same relation that says torque is related to V over F squared multiplied by the slip speed. You know now that the V is constant, so we can get it out of this direct relationship. That means the torque is now related to 1 over F squared multiplied by the slip speed, because V is constant for now. Okay? And you know that the frequency is directly related to the synchronous speed, because the synchronous speed is basically 120 F over P, and we're not changing P. So I can just take the frequency of this relationship and just replace it by the synchronous speed. So the torque is directly related to 1 over the synchronous speed square multiplied by the slip speed. And now it is your new relation that you can take care of here beyond the rated frequency. That means the new torque over, I'm gonna say the rated torque, equals the reciprocal of the synchronous speed. That means the synchronous speed rated over the synchronous speed new, because it's just 1 over the synchronous speed, so we'll give them just flipping up, multiply by the slip speed new over the slip speed rated. Okay? The new torque is given to be 15 Newton meter, and the rated torque was 30. The synchronous speed rated is 1200 RPMs divided by the new synchronous speed, all squared. The new slip speed, which equals the new synchronous speed minus the new mechanical speed, how you calculate the slip speed anyways, over the rated one, which was 40, if you remember. The new mechanical speed is 1300 RPMs, that's given. So this gives you some sort of just all here is known except for NS new. If you rearrange that, it will give you some sort of this equation. 20 NS new squared minus 1200 squared multiplied by the new ns, the synchronous speed nu, plus 1872 times 10 to the power 6. That equals 0. It's a quadrature relationship, quadrature equation. You can actually just draw it yourself here. It's pretty easy, okay? By solving this one, you will find out that the new synchronous speed equals 1324.4 RPMs, which you know equals 120 of the new frequency over number of poles, which is 6. So you can find the new frequency here to be 66.22 hertz. Like you see in here, the new frequency is higher than the rated frequency, which is 60 hertz, as expected. Okay, guys? So that's the whole point. Look at your mechanical speed that wants to drive the motor at. I'll look at its relationship with the rated synchronous speed. If it is less than the rated synchronous speed, that means you are in the rated on the linear region. V over F is constant. If you're beyond this rated synchronous speed, that means you are in the region while the voltage is kept constant, so that you just go with this ratio rather than just the torque is directly related to the slip speed. Okay, guys? Okay. To make sure that everything is just going good, let's look at another problem to look at here, okay? They're the same thing here. Okay. Okay. That is another problem. It's saying that a 4-pole 60 Hz Y-connected induction motor has the following parameters. Okay, so it's just giving you this information that the number of pole is 4, the rated frequency is 60 Hz, and it is Y-connected induction motor, and he's giving you these equivalent circuit parameters. Okay. And by definition, this is the equivalent circuit parameters at rated frequency. Okay. Does the frequency has anything to do with this? Yes, because you know the x's, x1, x2, and xm is depending on the frequency. Okay. So he's giving you those, and that means that's the rating of the machine. So those guys are just at the rated frequency. Okay. Under rated conditions, the slip speed is 72 RPMs. So the slip speed rated equals 72 RPMs. And the torque rated, because it's just saying those are the rated conditions. So the rated torque equals 9 Newton meters. And I1 equals 6 amps. Okay. I1, that is the current of the stator, phase current of the stator, I1. Again, that is the rated equals 6 amperes. Okay, guys? And what he needs you to find him now, calculate the slip speed and line current when driving a 6 Newton meter load at 1500 RPMs. So it doesn't want you to work at the rated conditions. Rather, he wants you to go here, which is the torque nu equals 6 Newton meters, and the mechanical speed nu equals 1500 RPMs. And for these conditions, we want you to find him the new slip speed and the new line current, I1 nu. By the way, the line current shouldn't be I1 because I1 is basically the phase current, but for Y connected machine, as he said, that's a Y connected machine, or he didn't say, that's by definition the connection of the machine. The line current equals the phase current, so they're equal, no problem. Okay? But if the machine is delta connected, that means whatever you find I1 in the phase current, then you need to convert it into line current by multiplying it by square root of 3 to find the line current. Okay? Just small things that can get you wrong. Okay? Let's see what we'll do now. Okay, guys? So we're gonna do the same things like before. First thing first, we need to find the rated synchronous speed because that will tell us in which zone we're working at. Yeah? That 120 F rated over 60, over number of poles. It's different here. So 120 F rated is 60 over number of poles is 4. So that is basically 1800 RPMs. Okay? Now let's look at the new mechanical speed given. It is 1500 RPMs, which is less than the rated synchronous speed. And that means we are working at V over F is constant. It is the linear region. Okay? So V over F is constant and the torque is directly related to the slip speed. That's the information you know once you know which zone you're working at. Okay? Okay. So let's find him the slip speed. Using this relationship, you know that the torque nu over the torque old, which is basically the rated torque, will equal the slip speed nu over the slip speed rated. Yeah. The new torque is given to be 6 and the rated torque is 9, so 6 over 9 will equal the new slip speed divided by the rated slip speed, which is already given at the beginning here to be 72 RPMs. Yeah. So from this, you are gonna find the new slip speed to be 48 RPMs. Okay. That's his first objective. He wants you to find the new slip speed. And for now, he wants you to find the new current, the new stator current of the machine. Okay? That's new. I'm gonna draw you again the equivalent circuit because that is how we can go to find the current here actually. Okay? That is V1 and that is the current I1 we want to go with. The typical thing to think of, if you can just solve the equivalent circuit. If you know all these equivalent circuit parameters and you know the slip and you know the voltage, you can just find the total impedance and divide the voltage by the total impedance and give you the current. Easy. But the problem is we don't have the voltage. Maybe you know that for this, all these givens here, he didn't give you the voltage. That means you cannot just simply solve the equivalent circuit to find the current. We need to go around with something else. Okay? How we can go this actually? See what's given in your hand. At here, he's giving you the torque you're working at and the speed you're working at. And that's basically good piece of information to go with here. Okay? How like this? Let's see. Okay. Fine, so going from here, you're gonna use this actually to find the current I1. Okay, and by the way, that is the current I2. Why I'm going with this? Because you have just given here the torque. You know the torque new because everything here just, we need to calculate everything at the new condition. So new torque equals 6 Newton meter, yes? And how you calculate the torque in the machine actually, if you remember, that equals the air gap power over omega s, yes? The air gap power is basically 3I2 square R2 over S. And you still have omega S down here. Yeah? Okay? Make sure just relate everything here. So everything here is related to the new condition, so please keep that in mind. So that means there is I2 new and omega S new and the slip new. Everything here is new. Why not R2? Because R2 does not depend on the speed of the machine, so it doesn't just play with the frequency, it's just a resistance, so it's over there. Okay? So what do you have here in hand you can go with? First of all, we can find the omega S new, which equals 2 pi over 60 multiplied by the synchronous speed nu. Okay? Can you calculate the synchronous speed nu? Yeah. The synchronous speed nu is basically the new slip speed, which we already calculated, plus the new mechanical speed, yes? The new slip speed, we find it to be 48 RPMs. And the new mechanical speed is already given at the beginning here. He wants you to work at 1500 RPMs, yes? So that is at 1500 RPMs. So that is 1548 RPMs. That is the new synchronous speed. Okay, keep that in mind. So you can just put it here to find omega S. Easy. So you can find omega S. And you can find also the slip nu, which equals the synchronous speed nu minus nm nu, which this differential is basically the new slip speed, multiplied or just division by the new slip speed, the new synchronous speed, sorry. Okay, so the numerator of this is basically the slip speed, which is 48, okay, by the new synchronous speed, which is 1548 RPMs. Okay, that is your new slip. So everything in this relationship now is known, because you know R2, it's given. Everything is known, so you can find I2 actually, because this torque is given. And everything here has been calculated. So you can go directly to find I2 from here, which is I2 new. You will find it to be 3.64 amps. Okay, that's the magnitude. I hope you remember. That's torque calculation, so that is the magnitude of the current, not the magnitude and angle. So that's still the magnitude. So using the torque, we managed to find I2. Okay? Can this help us? Yeah. From this equivalent circuit, if you know I2, you should be able to find I1. Because basically I1 is the total current that is going to be divided into two halves, one going to IM and the other one is I2. Okay, so by just the basic circuit relationships of the current divider, you can basically find I1 from here. The current divider is saying that I2 will equal the total current I1 multiplied by the far impedance, which is JXM, divided by the total of the two impedances you're dividing by. So that is JXM plus JX2 plus R2 over S. So from here, if you want to find I1, it will be I2 multiplied by R2 over S plus JX2 plus XM, that is divided by JXM. I2, we have already found it, 3.64. I need to find this. R2 is already given and it's not changing. Okay, the data given by the first, and that is 0.76. That's not changing. This slip is the new slip you've just found here to be just 48 by 1548. So what you need to find is X2 and XM. Those are given at the beginning, yes? No. The beginning X's are at the rated frequency. It's given in the problem that's rated. Should it be different here? Yes, because you're working at different frequency. Keep in mind that any x is basically 2 pi fl. That means x is directly related to the frequency. So if the frequency changes, the x changes. That means you need to find x2 new, which is basically x2 old multiplied by f new over f old. Okay? Can you find the new frequency? You should be able to find the new frequency because you already found the synchronous speed new, yes? The synchronous speed new, 1548, equals 120 f new over the number of poles. Number of poles equals 4, so you have everything in hand to find f new. So f new, you can find it easily, okay? So the f old is the given 60 Hz, which is the rated frequency, and f new I've already calculated, and x2 old is the one given in the equation, in the problem, which is 2.4. So you have everything here to calculate x2 new. The same idea goes with xm, which is xm old, the given in the problem, multiplied by the new frequency over the rated frequency. xm old is the given to be 54 ohms. The new frequency, you can calculate it easily, and the rated frequency is 60, so you have everything in hand so you can calculate this. Okay, guys? So for this equation, we have now found everything. That is x2 new, xm new, and that's xm new. Okay? Because again, they're depending on the frequency. I didn't do this with R2. I just put the value in the problem because the resistance doesn't change with the frequency here. Okay? That's it. Just put those back in the equation you just found, and this will give you I1 new to equal 4.26 amps. That's obviously its magnitude. And because it's Y connected machine, the I line equals directly the I phase, which is I1. So you don't need to convert it anyway. So that is your final. Okay, guys? That should be easy. The whole point is to make sure what's changing with the frequency and what's not changing. Okay? So for this, you have the axis changes the frequency, not the resistance. And everything changing here, the slip changes and the torque changes and the synchronous speed even changing because we're using V over F speed control. That means we're changing the frequency to changing the machine's speed. And changing the frequency changes your synchronous speed, and this in turn changing the slip speed and slip, and also changes the X's, the reactances, and the equivalent circuit parameters. So don't get confused with this. If you have the voltage of the machine actually just given here, you could just use the equivalent circuit directly. Okay? How? If he was giving you in the problem the rated voltage of the machine, you can calculate this V1 because now V1 is also V1 new, that we remember. It will be the same idea, V1 new over V1 old, which should be the rated, if it is given, will equal F new over F old, which is the rated frequency also. Why? Because we are in the linear region. V over F stays constant at its rated value. Okay? So the new voltage over the rated voltage equal the new frequency over the rated frequency. Okay? So from this, you can find V1 new because you know the new frequency, you can calculate it easily. Okay? So from this, you can calculate V1 and just solve the equivalent circuit directly without going with this idea of calculating the torque and finding I2 from it and finding I1 from I2. Okay? If you know V1, you can just solve the equivalent circuit. But you still need to find the new slip, the new X2, a new X1, a new XM, all those stuff. But unfortunately, it didn't give you V1 here, so we have to go with a different approach. Like we said, it's just using the torque given and go with the torque equation to find I2 and find I1 from it. Should be easy, the same idea. But like I said, just make sure you're just accounting for everything that will change with the frequency change, like we just illustrated before. Okay, guys? Okay. That's it. So I hope this just solidify your theoretical concepts about the V over F speed control stuff, and how to just go from different zones, from the V over F constant zone to the zone where just V stops changing and the frequency can go higher than the rated value, and how you can just use this to actually determine how to set the frequency of the machine and the voltage to just find the speed you want at a given load torque. Okay, guys, that's how we do this. Thanks so much for joining me today. Just take time to just try and redo these problems yourself. That will help you so much, just making sure you understand every concept here, and I will be happy to answer any questions you have just by emailing me. Thanks so much, guys, for joining me today, and looking forward to seeing you next time.